Hello and welcome back. Today we'll be going over a very simple movement controller for 3D movement. Before we dive in, remember that there are many different ways of accomplishing the same thing with different types of programming, but there's also just different things we can do. Now there are also many improvements we can make to the system, including adding a more complex state machine, which we'll cover in the future. Now with that out of the way, let's just go and really quickly set up a really simple character. So for the character, we're just going to be using a character body 3D here. Very quick overview. We just have, just a main level, some objects for us to move around, some floor. One thing that I may have forgotten to do, and this is something I always forget to do, is I always need to highlight these, and under use collision here, if we just click use collision, that means these will now be considered collision shapes. I always forget to do that. Control S and save. Now for our character body 3D, we're just going to call this the player. I'm going to hit Control S and save under Entity. I'm going to save it under an Entity folder because that's where I want my player to be. First thing I actually really want to do here is make sure if we go into the project settings, go into input map, we need to set up our inputs, right? So we're going to need to set up inputs for our moving left, right, forward, backwards. We're also going to be handling sprint, walking, and jumping. So let's do like this. Let's just go left, right, up, down, walk, sprint, and finally jump. Now I just need to map these to the correct keys. So I'm going to be using WASD keys for this. You can use whatever keys you actually want for this, or you can do multiple key bindings as well. Walk will be control, sprint will be shift, and jump will be space. There you go. And hit control, or I'm going to hit close. And now I'm going to start by making a fun little resource that I actually like to use for this stuff. So I'm going to go into my components folder here. It's an empty folder. I'm going to right click, hit create, and I'm going to create a new script. And this is going to inherit the resource class type. And I'm just going to call this the movement input component. Now, there is a reason why I've started to really enjoy using resources for stuff like this, and I'll kind of show you as we go. But we're going to give this a really quick class name of the movement input component. And this is one of those things that I find really fun to do. Now, you don't have to do stuff like this because there is a different way of doing it, but I actually enjoy doing it like this. So first thing I'm going to do here is I'm just going to go create a new function for get underscore movement underscore input parentheses, and it's going to return a vector2. Now this is going to be a bit weird, right? Usually what you do when you do movement is you do if input dot is action just pressed left, right, up, down, and then you basically have your code after that. What I've actually really enjoyed doing with this is actually just having this return whether it's true, false, or what direction we want to move in. So what I'm actually going to do here is return an input.get underscore vector. That way I can kind of control the vector that I get from it, right? So I could go one step further if I really wanted to with this and create a new variable here for movement. I cannot spell the word movement. Wow. There we go. Call it movement direction of type vector2, and we'll set that equal to input.isAction, dot get underscore vector. And now I just pass through the vector that I want to get, right? So I want to get left, right, up, which never likes to appear on the autocorrect there, and finally down. And then in the return here, I can just return that movement direction. Now, this might seem like a few extra steps for kind of accomplishing just getting this, right? But what this actually allows you to do afterwards is I can now apply kind of whatever I want to inside of here to do multiple different things, right? Now, that's not going to be something we actually put to use in this, but for future reference, it is really good to allow you to kind of build upon certain little systems that you have and not just go with the kind of raw input. So the next one is just going to be a function for get underscore sprint underscore input. And this is just going to really simply return a boolean. I need to remember my parentheses. There we go. And this is just going to return the input dot is action just pressed, and this is going to be for sprint. So we want to put in sprint is action just pressed for sprint. That like this itself is boolean. So if it is pressed, it will return false, or it will return true. If it isn't pressed, it will return false. So this is like one extra step, but once again, you can store it as a variable and then make modifications to it or do certain things when you're doing that. So really, really cool. So the next one is git func get underscore walk underscore input. This is going to be returning a boolean as well, same thing as before. So this is actually pretty much going to be always the same thing, right? So we can more or less just copy this line here and then just paste it where we actually need it to go, and then change walk or change sprint to walk. And finally the jump input. It's very cold today, so my hands aren't really deciding to type the things that I want them to type. So now we just pass through the jump input. So we're, returning a ball with something that already returns a ball. It's just a fun little thing to do. I'll show you how we put this to use in a second as well. So what we're going to do next is we're going to add a player, or a script to our player here. So let's just go and add a script to our player. Let's get rid of all of the basic stuff here, and we're going to call this underscore, so class name underscore name character, we'll just call it player. There we go. So for the player, we more or less just have to, hook some of the code up when we have it done. But what we're going to do first here is we are doing an onReady, and we're going to do an onReady for the movement underscore input underscore component. And what we can do is typecast this as a movement input component and set that equal to movement input component.new. So what that's going to do is basically create a new resource on this player that is the movement input component, which means we can now use this functionality. This is just a really fun composition method that I found with resources. But let's get to the kind of meat and potatoes of this, right? Let's get to the actual componentization of the movement, actually handling the movement itself. So for this, I'm going to create a new node, and this is going to be of type node. Doesn't need to be a node 3D, it can just be a normal node. It also doesn't even need to be a node. It could technically be a resource if you're willing to do some fun programming things, but we're just going to work with just a node for now. I'm going to save this under my components folder, and I'm going to add a script to it. Now, we don't need pretty much anything in here. We're going to need to give this a class underscore name of the movement component. And we're going to need a few exported variables. The first one is going to be the base underscore speed. This is going to be of type float, and I'm going to set this equal to 5.0 for now. The next exported variable is going to be the sprint underscore speed of type float, and I'm going to set that equal to 8.0. Next one is the walk speed. Once again, float. These are all pretty much just going to be floats, so I can stop repeating myself for the word float. And finally, the jump height. So we have the exports handled. Let's go and create another normal variable here for the current underscore speed. It's going to be another float, and we're going to set that equal to 0.0. So with how I want to handle movement with this, what we're going to be using here is two things. We're going to be using an enumerated state machine to handle the difference between neutral, so just normal running, like normal speed, crouching and sprinting, or walking and sprinting in this case. And then we're going to basically be using that to modify this current speed value, and that current speed value is what's going to modify our player's velocity. So first thing we should do here is create a new enum, or a new enumerated kind of state setting or state list that we have here. So enum movement underscore states, and this is going to just be, I'm going to call it neutral. Neutral is nothing is happening, like no extra input is happening other than walking. Speaking of, we'll do walking, and then we'll finally do sprinting. Now you'll notice I keep getting confused between walking and crouching, and that's because with this, I'm not actually adding crouching, I'm going to be adding walking, but you could very simply add walking or crouching the exact same way that I'm doing here. So we now have a movement states variable. So let's go and create a new variable for the current underscore movement underscore state to make it really clear that's what we're doing. And this is going to be of type movement states, and we're going to set that equal to movement state dot neutral. So the starting state for us will be the neutral state. Now with the states set up, let's actually kind of just start handling the movement itself, right? So the first thing we want here is a function for handling the acceleration of our character. So this is going to be the, moving forward or in X direction. This is going to be a void return. I'm going to write pass for now because we're going to need a couple of parameters passed through. Very first thing I want to pass through is going to be the entity or the thing that actually wants to do the moving itself, right? So this is going to be an entity of type character body 3D. And then we're going to want a target underscore direction, which is going to be a vector too. So other thing with this is the way I'm designing this is going to be so I can kind of attach this to anything, and providing the inputs being placed in are correct, anything will be able to move. Now that doesn't specifically mean that just the character will be able to move, right? Because with how we're setting up movement input here, this is just passing in booleans and a vector too. So that's pretty much how we're going to be handling this, which means if we want an NPC or an AI to use this like functionality, they've just got to pass through booleans or a vector too. They don't actually have to pass through keyboard inputs. Now that is really, really cool. So let's create a new variable inside of our handle acceleration function here. We're going to call this the direction. This is going to be of type vector 3 because we're in the 3D plane, right? And I'm going to more or less just kind of talk you through how this works, right? First thing we're going to need here is the entity.transform.basis. So if you've watched any of my videos, you know I'm very much a 2D person, which means relying on this stuff is very, very confusing to me, or it was very confusing to me, but I've learned a lot more, gotten more into 3D, I've been enjoying it quite a bit. So the basis of this transform is composed of by 3 axes, basis X, Y, and Z. Together, these represent the transform's rotation, scale, and shear. So we want to basically grab the basis, so the entire transform of the entity itself, and then we want to multiply that by a vector 3, and we want to pass through here the target direction dot X, the floating value for Y, which is going to be 0, and the target direction for the Y in the Z coordinate, because basically speaking, with how we're going to be handling this, our W, A, S, and D, right, are only X and Y because it's a vector 2. So forward and backwards is our X. Sorry, left and right is our X, whereas forward and backwards is our Y. My brain is getting confused. Yes, basically we don't want to actually pass anything through on the Y of the vector 3 because that will be kind of jumping up and down, so going up and going down in a 3D kind of space rather than going forward and backwards in a 3D space. The Z direction, or the Z axis, is the thing that controls the forward and backwards movement. I hope that is explained well. So now what I'm going to do is I'm just going to call the direction and I'm going to just apply a normalization to it. So I'm just going to go direction.normalized. And now we're just going to check if the direction, so if direction, what does that mean? Well, that means if the direction actually is something, right? If it's not null, if it's not 0, 0, 0, if it is something, it needs to do something. So if the direction is something, we need to just grab the entity.velocity.x and set that equal to the direction.x times the current speed. And then we're going to do the same thing here for direction, or for entity.velocity.z, because we want to modify the z coordinate, not the y, and we want to pass through the direction.z this time, times the current speed. And that's it. That's really simple, just like forward, backwards movement handled. So now, next thing I want to do here is I just want to throw an else in. I want to say if the direction doesn't equal anything, I'll grab the entity.velocity.x and set that equal to a move toward. I want this to move from something to something. I want to move it. I want to move the entity.velocity.z to the current speed. And this should be the x. There we go. And finally, I want the entity.velocity.z to be equal to move towards, and more or less just do this same exact thing here, but for the z-axis, like so. So yeah, that's pretty much our acceleration handled, right? Our acceleration is going forwards and backwards. That's done. Now, the next thing that I want to do is handle, let's just go straight into the jumping, right? Because jumping is actually quite an easy thing to usually handle and stuff like this. So let's just go handle underscore jump. Let's pass through the more or less same parameters here. So we're going to need the entity of character body 3D, and we are going to need a is underscore jumping boolean pass through as well. And then I can just do if is jumping entity dot velocity dot y is equal to the jump height. So that's going to basically pop our character up by a certain amount, right? That's our jump handled. And that's more or less it. That's pretty much it. And now you're probably wondering, well, how about walking, right? How about things along those lines? So let me actually show you. Yes, you're probably wondering, we've got our acceleration handled and our jumping handled, but where are we applying the sprint speed, the walk speed, or, just the base speed in general? Where is any of this stuff actually happening? Well, under the, actually, we'll do above handle acceleration. Above handle acceleration, we are going to create two new functions. The first one is going to be handle underscore movement underscore state. Now, this is the thing that's going to be in charge of basically saying what state are we in. We're just going to match the current movement state. And we're going to go movement state dot neutral. And we're just going to set the current speed equal to the base speed if we're in the neutral state. And the next one will be the movement state dot, we're going to go with walking next. We're going to go current speed is equal to the walk speed. And finally, we're going to do movement state underscore, or movement underscore states dot sprinting current speed is equal to the sprint speed. And that needs to be removed, and there we go. So this is basically where we're going to be modifying and managing our speeds. New question though is, how do we actually change our state to change the speed? Well, that's where the next function is going to come in. So I'm going to write func. I'm going to go set underscore movement underscore state. And this is going to basically need to take in two booleans. It's going to need to take the is underscore walking boolean and the is underscore sprinting boolean. Now I'm going to return type void that because we don't need to return anything, but we do need to actually modify our stuff, right? So we're just going to go if is underscore walking current movement state is equal to movement states dot walking. And then we're just going to do a quick elif in here. So if, well, elif is underscore sprinting. So the next one's going to be sprinting. elif is sprinting current movement state is equal to movement states dot sprinting. And then we're just going to cap this off with an else statement and just set the current movement state equal to the movement states dot neutral. So let me do some little line separation here to make this a bit easier to read. So what is this actually going to do? Well, we're going to pass through two booleans, right? We're going to pass through the walking boolean and the sprinting boolean. Now, one of these is going to be false, or both of these is going to be false, but only one of these can be true at any given time, right? So if is walking is true, we're going to set our movement state to walking. But if is walking is false and is sprinting is true, it's going to set our movement state to sprinting. And if both of them are false, then our movement state is neutral. And then we're going to basically match that. We're going to run this as our match statement, and we're going to go, if we are in any of these states, this is what our current speed needs to be set to. And then in acceleration here, we are literally just modifying the direction times the current speed, which is our speed modifier, and that's it. That's quite literally it. We are done. That's movement actually handled. The only other part of this is just hitting Control S and saving, and then connecting it to our player. So let's go and, get this connected to our player. So for our player, first thing I want to do here is just create a quick function for handling the underscore gravity, because gravity is an important thing. It's going to need a delta of type float, and it's going to have a void return, and we're just going to go if not is on floor, which is a fun little built-in function for Godot. We want to apply the velocity, we want to go plus equals get underscore gravity, which is another built-in function. We want to times that by delta, so we handle the gravity correctly. And now what we want to do are actually modifying our character correctly, right? So I'm going to just create some space above that function. And we are going to need to start actually designing how our character is going to be set up, because there's a few things that we actually need to keep in mind when we are kind of messing around and designing the actual character itself. So what I'm going to do here is first I'm going to go into the 3D scene. I'm going to hit Control A and I'm going to add a collision shape to the player here. This is just going to be a very quick capsule shape. I'm going to move that so it is touching the floor like so. And now on the player one more time, I'm going to hit Control A and I'm going to add a node 3D, which is going to just be the head pivot or the head anchor. So basically this is just where the head will be, right? And that can be pulled up to the near top, not the direct top, but somewhere near the top middle of the character like so. Hit Control S and save. Now I'm going to add a camera 3D to that. So what that is going to allow us to do is actually start messing around with the camera. So I'm going to hit Control S to save. I'm going to open that player script once again, and we're going to start actually kind of modifying things. First thing that we should probably do is actually get some get our movement component in here, right? So let's just do an export var movement underscore component of type movement component. Set that equal to null. Hit Control S and save. That means we now go to our player, hit Control Shift A, or you can right click, add child node, or right click, instantiate child scene, and we want to add the movement component. I'm going to put that at the very top of our player here. I'm going to go to the player, click assign, click the movement component. Now what I'm going to do is I'm going to open up a quick built-in function for the unhandled input. What we're going to do here is we're just going to check if the event we are passing through is of type input event mouse motion. So this is basically just going to see if our mouse is moving, right? And if it is, we want to do something with that. Well, what do we want to do? Well, we want to grab the rotation underscore y. Now we're going to use a degrees to radians function, because when we spin our mouse, it's going to be in degrees and we want it in radians. So we're going to use deg to rad. We're going to pass through the negative event dot relative dot x. We're going to go times the mouse sensitivity, which is something we haven't actually set up yet. So let's go and do that. Now, this isn't something I suggest having in your player script. This is something that I actually suggest having in a more globalized, like a globally accessible way, because you're going to want to use this in multiple different places. But for now, just the mouse sensitivity, there we go, being a flow of 0.05 for now. Just having it here will be fine. Let's go and add the mouse sensitivity like so. But yes, now what we're doing is rotating the y based off of the negative side of the relative.x, and we're applying the mouse sensitivity or multiplying that by the mouse sensitivity. So now what we're going to want to do is create a quick on ready here for the head pivot. I'm going to drag, control, drop, and you can see we now have our little head pivot here. We are just going to grab that head pivot dot rotate underscore x, and we're going to pass through, once again, deg to rad, the negative event dot relative. I have just realized where I'm going wrong here. This needs to be if the event is an input event mouse motion, that will actually allow us to use the relative. What is the relative? The mouse position relative to the previous position. So basically seeing where the mouse is and where it was, and then doing some math based off of that. So we're going to grab the dot y and times that by our mouse sensitivity like so. And next we're going to finally grab the head pivot dot rotation dot x, and we're going to set that equal to a clamp. Now, what we're going to be doing here is clamping the rotation of the X between -80 and +80. The correct way of doing this would be +8 or +89 and -89. This allows you to look nearly all the way down and look nearly all the way up, but doesn't allow you to spin the camera like a mad person. So, it basically just stops weird vomit-inducing things. So we're just going to grab that rotation again. So head pivot.rotation.x, because that's what we want to clamp. We're going to clamp this as a degrees to radians. -80. I use -80 because it's kind of comfortable to me. I'm going to do the same thing again, deg to rad, and we're going to just pass through 80. I'm going to hit Control S and save, and that's it. We have our actual movement or our mouse kind of inputs being handled. Now there's one last thing I'm going to do here, and there's a few different ways of doing this. You don't need to do it in unhandled input, but I find it kind of functional because it's unhandled input. You're already handling input in one place. You can actually start adding to that here. I'm just going to grab the movement component, and I'm going to use dot set movement state, and I'm going to pass through the movement input component dot get walk input, and I'm going to also pass through the get sprint input here. So movement underscore input component dot get underscore sprint input. Now we're going a bit large with the line, but this will do. And there you go. We are now actually effectively setting our movement state, right? We just need to apply that other function that we had. Let's go and have another quick check here. Let's go to the movement component. We're setting the movement state, so now it's going to switch between these three. We now need to handle the movement state and then apply our acceleration and our jumping. So what we can do is we can create a new function here for the physics process. And first I'm going to call that handle gravity. I'm going to pass through delta because we need gravity being handled. Now I'm just going to grab the movement component dot handle movement state, and this is just going to help us modify our state. Then I'm going to pass through the movement component dot handle acceleration. I'm going to pass through self because we want to move this specific thing, right? And then I'm going to pass through the movement input component dot get movement input. And then I'm going to call the movement component dot handle jump. Once again, pass through self, and then grab the movement input component dot get jump input. And then finally, to get this to run and function, we actually need to call one more function, and that's a built-in function called move and slide. And if I hit Control S and save, we should actually be pretty much done here. This is pretty much everything we need to do to have movement working. Now, I'm being a bit ballsy here, and I'm not testing this as we go, which, is, you usually want to test as you go. I'm going to keep the speeds and the heights all the same. I'll go to the 2D scene, the 3D scene here, go to my main, go into my entity container. It's just a little 3D node that does nothing else other than hold my entities. Place the player in. Make sure the player is in the correct spot, like so. I'm just going to put him just a little bit off the ground. I'm going to click play, and as you can see, I haven't tested this at all. And now I'm going to pray that it works. Give it a second. And there you go. Movement is working. Now we are having some slight issues here of the mouse, moving off of screen and not being able to exit. So very quickly, I'm going to open up main here, and I'm just going to go func. Let's just very quickly go to the project settings. A really good thing when you're creating 3D games, by the way, is to just create a debug underscore force underscore quit function. I'm just going to put that as escape for now. I'm going to grab the unhandled input, and I'm going to go if event.isAction just pressed debug force quit, then what do I want to do? Well, I just want to go get underscore tree dot quit. So what that's going to do there is basically, I need to remove that, there we go. That's going to allow us to do this and exit the game. So when I full screen, I don't need to think about it. Rename my main file so it's being just a little bit grumpy. This can more or less just be ignored. That's me setting something up slightly wrong when I was originally doing things. There we go. So what we're going to do here is, oh yes, on ready. So we're going to go func underscore ready. We want to grab the, let's see if I remember how to do this. Input dot set underscore mouse underscore mode. We want to pass through the input mouse mode of captured. And now we hit Control S and save, and what should happen is, there we go. And we now have movement and jumping. As you can see, it's a little bit floaty, but let's see, yeah, we can sprint. Sprinting works. We can slow our walking down, that also works. Yeah, that's all pretty much handled. Now there is some slight issues that we're going to have here, and that comes from how, let's go to the movement input here. It comes to how this is being handled. Now I kind of left this in because I wanted to make sure you kind of understand how this works. So you see how we're doing get sprint input. Is action just pressed sprint? Well, this means if it has just been pressed, this is true. But the next time it comes and loops over this, it's not being pressed anymore, it's going to be false. So, or it's not just been pressed, it's going to be false. So we actually need to change this to if it's being held, right? Because you want to be able to hold sprint to do that. So what I can do here is just remove that and do is action pressed for sprint and is action pressed for walk. Hit Control S and save. And now what should happen is, you see that object there, I'm walking backwards and forwards, I sprint and it no longer breaks. I can sprint backwards and forwards all at the same speed, and I can do the same for walking. Now with all of this done, if you want to be able to, make it less floaty, you can go into your project settings, general, and you can grab the gravity for the 3D here, and you can just change the default gravity to kind of whatever you want. You can set up your own gravity variable in a different place. I'm just going to leave it as is so you can modify it as much as you want. But with that said, thank you for watching. I just want to say thank you to everybody who supports the channel. It really allows me to make more content and tutorials for you all, and yeah, just puts a smile on my face. Now, thank you for watching, have a great day and a great game dev journey.